This lesson will focus on integrating exponential functions. If you've already looked at differentiating exponential functions, you know that if y is equal to e to the power of x, then dy by dx is e to the power of x. That's one definition of the exponential function, that it differentiates to itself. Integrating an exponential function, remember, is like antidifferentiating. So the integral of e to the power of x is e to the power of x. But don't forget, when integrating, we also need to consider the constant of integration. We also know that if we differentiate y equals e to the power of f of x, some function of x, then dy by dx is the derivative of that function multiplied by e to the power of f of x. So again, in reverse, to antidifferentiate or to integrate something of the form f dash x e to the f of x, the result will be e to the power of f of x, and don't forget the plus c, that constant of integration again. So looking at a couple of examples, firstly the integral of e to the power of 6x with respect to x. Now the 6x here is our f of x, and so f dash of x is 6. So we know that if we integrate 6 e to the power of 6x, we're going to get e to the power of 6x plus c, using this result from above. But in the question here, we've got e to the power of 6x, not 6e to the power of 6x, so we need to divide this by 6, and so the result is e to the power of 6x over 6 plus c. In the second example, our f of x is x squared, and so our f dash of x is 2x. So again, from the result above, we know that the integral of 2x e to the power of x squared is e to the power of x squared plus c. But our question is asking about 10x e to the power of x squared, which means we need to multiply this by 5. And so the result we're looking for is 5 e to the power of x squared plus c. Thirdly, we'll look at a question which involves definite integration. We'll start the same, so we can see our f of x is 2x, and the derivative of that is 2. So we know that when we integrate f dash of x e to the f of x, we get e to the f of x plus c. But we're trying to integrate 8e to the power of 2x, not 2e to the power of 2x, so we need to multiply this by 4. So that's the result if it were indefinite integration, but we're using definite integration. So the integral from 0 to 1 of 8e to the 2x dx, 4e to the power of 2x, and we're going to substitute values of 1 and 0. Now remember, we don't need to use the plus c, because when we substitute the values of 1 and 0 and subtract, the plus c's will cancel anyway. So now we'll substitute in those values. This is 4e to the power of 2 minus 4e to the power of 0. So 4e squared, and then e to the power of 0 is 1, so that's minus 4. And we can factorise this final result just to tidy it up a bit.